Good afternoon, everyone. Welcome to this live session, second live session on the course on hydrogen energy. I will take questions from the discussion forum and whatever posted here. So you can start typing your questions in the chat box. Until I get a question in the chat box, let me pick up certain questions from the discussion forum to answer. It's been asked, one of the questions in the discussion forum which is being asked is that for MOF, the bond which is being formed is weak. And for carbon dioxide capture, like the bond is stronger. So it's being asked that the adsorption. So depending upon what is the surface, so it depends on both. What is the adsorbate and what is the adsorbent, that the interaction between the two differs. Now in this case, if MOF you are using as a adsorbent, in that case the bonding will depend upon what molecule you are adsorbing. So in case of hydrogen, the bond formed is compared to the other, like some of the other adsorption based materials, the adsorption bond energy is slightly higher, but still compared to the metal hydride, so there is a range of bond energies depending upon which material, adsorption based material is being used. So compared to metal hydrides, the bond energy, the bond formed is relatively weaker. Another question in the discussion forum is about storing hydrogen at high pressure in type 1 tank. So how can hydrogen embrittlement be avoided? Type 1 tank, usually as I have mentioned in the tank design, the tank are made up of steel, specialized steel, and which steel, what should be the strength of that material, that I have discussed. So one is we have to select the material appropriately. Then there are ways to avoid embrittlement, and we will see in further in the hydrogen safety, that we can still have a coating if required, so as to avoid direct exposure of any metal to hydrogen. And that coating should not only reduce embrittlement, but at the same time it could reduce even the sort of permeability as well. However, like in type 1 tank, these are made up of austenitic stainless steel, and for that the embrittlement is lowest. In storing hydrogen type 3 or type 4 tanks, low permeability can be avoided. How permeability can be avoided? So as per DOE standards, there is a limit, an acceptable limit which is allowed for permeability. Here in type 3, type 4 tank, we have both. So I have mentioned that the gas tightness is ensured by the inner liner, and the strength is provided by the carbon fiber reinforced resin. So the polymer is selected. They have to undergo a permeability test, specialized permeability test, so as to ensure that the permeability is as low as possible. So the choice of polymer is done in such a way that the permeability could be limited.
There is another question by Tejas. How to decide water flow rate in electrolysis? What is the main parameter to consider?
So when you are doing sizing, you have to also look at the capacity. So what is the required flow rate, and based on that you can do the calculation onto the water flow rate. So what is the requirement for the particular application, and accordingly how much amount of hydrogen or the hydrogen flow rate is desired. That you can you have to first know, thereafter you can do a calculation on the water flow rate.
There was one question in the calculation of levelized cost of energy of hydrogen. So do we avoid the any amount of oxygen that is being generated?
In the levelized cost calculation of energy, uh, it's not that we are ignoring the amount of oxygen being produced, because that oxygen which is being produced can also be used for medicinal purposes. So in that case, the revenue generated can also be included. So in a particular example, we could have not considered, but that also can be considered to find out the actual cost.
So there is a question by Prasad. Can you tell about PEM fuel cell sizing for fuel cell stack?
Sizing. Uh, Actually, it may not be possible here because that may require many more details. Uh, but maybe you can write a mail to me and then I can. It may take some time to explain about the sizing. Yes, you can keep posting your answer questions here. Yes, please do write a mail to me, Prasad.
This has been a very
It's like about lecture notes, slides, reading materials was not provided so far. May kindly do the needful. Uh, Transcripts are being provided. These are being uploaded now. Reading material references have been indicated in the course introduction. Uh, Slides, these will not be, slides won't be available, but the transcripts, they have slide pictures there, and transcripts I think are being uploaded till which lecture are being?
We have sent almost by 20th lecture and received till 30, so we are correcting.
Okay, so this is some editing being done, so already uploaded till 20th lecture, and soon you will get till 30th this weekend. Regarding hydrogen safety, you will have to wait for the last section of this course. We have discussed about hydrogen safety at various places. There are safety standards, protocols existing. At the same time, at all the components, at all the utilities, or while having hydrogen refueling stations or electrolyzers, there are specialized components which are present to ensure the safety of such hydrogen based equipments, technologies. So that the answer you will be getting in hydrogen safety portion. Okay, I could see a question about the.
Lots of questions asking about the examination pattern.
Okay, so examination pattern. Uh, this will be from what is being done in the course itself, nothing outside that. And there will be certain portion which will be, so there is a set pattern by NPTEL, some portion from the assignments and some from recall, but everything will be from whatever is being done in the course.
Then question is why we use three storage, low, high, and medium after compression. Can we store in single tank?
Okay, so the question from Prasad is that we are using in three banks for storage: a low pressure bank, a medium pressure bank, and a high pressure bank. Actually, these are not three different at different pressure levels. Now, what happens is in the beginning, it's being at the same pressure level. Now, once you have connected it to the vehicle and filled to a certain pressure, its pressure reduces. Let's say starting it was at 88 bar, 880 bar, sorry. and then by filling we have reduced it to a certain level. Let's say it's gone down to 500 bar. Now it's not that we have to again fill it back to 880 bar. Still the pressure which is there of 500 bar in that particular bank can be utilized for further filling the vehicle. So now the same pressure bank which was called high pressure bank at 880 filling, it is now a medium pressure bank. So it's that these are the same three banks. Only difference is we are still utilizing the pressure bank even after it has reduced pressure, so that we can take advantage of its pressure level. Yes, we can store in a single tank, but then we know that the pressure difference that will decide how fast your filling is being done. So if the pressure level drops to say 200 bar, you cannot utilize that pressure for further refueling, or it will take too long for refueling. So in this multi-bank system, we are taking advantage of even the lower pressure presence of low pressure bank as well.
There's a question by Neeraj Singh. Dear ma'am, I want to simulate evaporation of liquid hydrogen in ANSYS Fluent, but I'm not clear with the properties, where to obtain the state properties.
You want properties of hydrogen?
Liquid.
Neeraj Singh, you can write to us and we will provide you the required properties.
We can give it in discussion forum.
I would request you to please post this in the discussion forum and we will reply with giving you the required properties. Please mention what you want exactly. Yes, any other doubt, any other question? Please keep writing in the chat box so that we can take up the question.
There is one question. So, how to calculate the losses in the fuel cell stack, and which standards do we need to consider while designing the fuel cell stack and its powertrain?
So when we say that the efficiency, so it's usually the different, we have talked about the different types of fuel cell, and we have seen that they have different power conversion, they have different efficiencies. Now that means the remaining, there are losses, but there some of the losses, these you cannot directly calculate, but then that consideration is there when you do a when you study the PEM, or when you do an IV or a power density curve you are looking at, you can identify. So these losses, theoretically we have already mentioned that there are three different types of losses involved, and the same you can calculate when you are studying the performance of a fuel cell.
And there was this question at the time of compression at 250 bar. What shall be the compressibility factor and how to calculate?
This compressibility factor, somebody has asked, if you can just go through some of the lecture, and now I exactly don't remember the lecture number. We have mentioned a plot for the compressibility factor, and from there with the pressure, how does that vary? And from there you can calculate at that particular pressure, like somebody has asked at 250 bar, what will be the compressibility factor. From that chart you can find out, from that graph you can find out at 250 bar what is the compressibility factor.
How to find cross fuel cell stack? There is again a question related to sizing.
Yeah, so that usually when we talk about fuel cell, the dimensions, then it is in terms of the membrane, MEA stack. So it's like how many centimeters by how many centimeters. Usually at present, like we are talking about few kilowatts. So uh, in a cell, like what is the dimension when we talk about what is the size in membrane, MEA size in area, or area in centimeter cross centimeter.
Uh, Question by Abhishek. Ma'am, any guideline code which can be referred to no ventilation requirement of electrolyzer building? Also, what is safe height for venting of hydrogen at the top of building?
Uh, Usually, if like possible, such type of hydrogen storage tanks or electrolyzers or any other utilities which are using hydrogen, they are kept in open. Open in the sense you can have a top shed, but it should have a sufficient flow of air and natural circulation should always be there. In case it is not possible, in that case, we will, I think that is already covered in the code.
Safety, which is about to come.
This will be in the safety part. There could be either a natural ventilation or there could be a forced ventilation. So there could be even on the top there could be certain blowers which could blow out the gas. So it would be a continuously exhausting the gas or an exhaust which could remove the gas from the but from an enclosed environment if it is not possible to keep those in a open environment. But usually such devices, even the hydrogen tanks, they are usually kept in an open environment.
There's one question by Ashish. How to calculate gravimetric storage capacity?
I think I have given the formula to calculate it. What we do is we calculate how much amount of hydrogen divided by the weight of the material plus the hydrogen. So that is how we calculate the gravimetric storage capacity of any material. You please check the formula that we have already given and it is usually done in that way. So the weight of hydrogen divided in that is being stored divided by the weight of hydrogen plus that of the material in which it is stored. Yes, please write your doubts in the chat box. Do you have any other questions?
Okay. There is one question which was already been discussed in the last session, like natural gas pipelines for being used for hydrogen.
Okay. After the compression of hydrogen at 700 bar, how to calculate temperature, density, viscosity, humidity of hydrogen? Actually, this is density. We have already, I have shown a graph how the density varies with pressure. Temperature will vary. So on compression, the temperature, you can even calculate what will be the final temperature. We have given a formula for that. This will be immediately after compression. Now, when it is exposed to the environmental condition, the temperature will finally, the heat will be dissipated and it will come to its ambient conditions, to ambient temperature. Density, that plot is there already. You please go through the properties of hydrogen. I think that was the first lecture. Viscosity and humidity, that will depend upon, it's not during the compression, but that will also depend upon, humidity will depend upon what is the inlet gas and how much amount of moisture was present. Usually there is, in the process, this is not changing of compression. So until there are more questions, you can share your experience with the course also in the chat box. I would be happy to hear that.
Combustion of hydrogen and burner design subject is going to be covered in our program or not?
Yes, so we have combustion being discussed and hydrogen being when we will talk about utilization, I think that week we have not yet reached on. So we will be Professor Sandeep, he will be discussing about combustion of hydrogen and he will also tell about use of hydrogen in IC engines. That will be, yes, that will be covered.
When we purge hydrogen, then dry, drain, open in turbine, that time some moisture come. What is the solution? When we purge hydrogen, dryer, that time dryer, drain, open in turbine, that time some moisture come.
Actually, a dehumidifier should be there if it is to be used so as to avoid any moisture. If it can cause up, like in case of turbine blades, there could be challenge. So it has to be dehumidified before entering into the dryer, before entering into the turbine.
Hydrogen dryer is provided for that moisture removal only. Which material is better for hydrogen piping for industrial and automotive?
So for whatever material which do not react with hydrogen, these are good for using it as piping. And in the pipeline, we have talked about certain material, what the pipeline has to be made up of in hydrogen transportation, and any material which is non-porous such that hydrogen should not diffuse from it. It do not, usually the requirement is that the material should, when exposed to hydrogen over a period of time with temperature and pressure, should not undergo embrittlement. The material strength should be such that it should not get it not it, and there should not be, it should be seamless. There should be as low number of joints as possible. The material usually used is austenitic stainless steel. The piping material, the pipelines we have already talked about in the course, that these should be made up of a particular material. I think that we have already discussed.
Request some input on the power module of electrolyzer unit.
Regarding the power module, and this will become like, as I told about the sizing of fuel cell, about the power module in an electrolyzer and its detailed layout. This being the course on covering on everything on hydrogen, including production, storage, transport, distribution, safety, and utilization also we have covered. It was not possible to cover in this particular course sizing components of each and every component, but you can connect with us and we can help you out with that.
Can we use hydrogen cylinder of iron instead of copper?
It should not be a problem. So good to see some of the comments as well.
Hmm.
Thank you, Saumedeep, Abhishek, Neeraj, Ashish. Yes, please post your question here on the chat box.
But this is the only like input mass for water for optimized water electrolysis. How many students are enrolled the course? 2,485.
It's 2,485 students who enrolled for this course. Yeah, please post your questions there in the chat box.
Till what time can we store hydrogen in tank?
So you can store time. So there is not until there is a leak, you can store hydrogen in a tank. So it's like not a, in liquid hydrogen there is a loss that we have studied. But if it is compressed state storage, there is no leak. It will be stored. You can keep it as long as possible. Also, in the metal hydride waste storage, also you can keep it. There is no, if there is no leak, it will be there. Only for liquid hydrogen, there is, because of the evaporation of hydrogen, and the tanks are not designed so as to hold very high pressures. And with evaporation, there will be a pressure buildup. You have to release that pressure, and that causes a loss of hydrogen or the filling level. Else, in compressed state storage or in solid state storage, if there is no leak, it will be there. Yes, if you have any further question, please post on the chat box. Exam pattern will be whatever being done in the course. From whatever being done in the course.
Is it safe to release the oxygen in atmosphere after electrolysis process at large quantity? Release oxygen.
So usually it is being released in the environment. But then it could be because that oxygen, and we have seen during the COVID times the value of that oxygen. So that could be used for medicinal purpose. As such, that could be tapped and can be stored and can be used for applications, medical applications.
How likely a leak will result in fire?
I think this question, we will talk about this question about the leak. So Mr. Satyanarayana, he has asked that about the leak which will result in fire. there are different aspects to it. Leak will not result into fire if until and unless there is an ignition source. Hydrogen, we know that it has a low ignition energy. There are chances of ignition if there is any ignition source, including any external heating element, some heater, nearby heating device, a flame, open flame, or some friction, or some other source which is nearby, and that leakage is in lying in the flammability range and comes in contact with that ignition source, then it can lead to fire. So if it is, and also that depends upon if that leak is in a confined space or an unconfined space. If it is in a unconfined space, that will, because of the high diffusivity and buoyancy, hydrogen will quickly raise and will get diluted, mixed with the environmental air. But if it is in a confined space and if it comes in contact with the ignition source, nearby ignition source, then it can lead to fire. And more detail we will see in the hydrogen safety part.
Is sloshing of liquid hydrogen a concern for storage and transportation? If yes, then what extent? What?
Yes, we have, I think that portion it's already live, wherein we have discussed about the sloshing of hydrogen. Yes, sloshing of hydrogen could be a concern. So usually sloshing, then there, if there is any, because of that movement, if there is a friction, so these tanks, I have also mentioned that these tanks are usually, there could be a static charge generation we should avoid. So we usually ground such tanks, and during the movement of that tank, that should be, this sloshing should be avoided. So that could lead to challenges that should be avoided.
Any software which can be used to derive total unit ramp rate, combine of electrolyzer, purification unit, and compressor to derive the recirculation flow for matching uniform ramp rate.
That I need to check. Abhishek, you have asked about any software wherein you can find out the ramp rate. So that I need to check and I will get back to you.
Then there is a question from Raju sir. Has the metal hydride cylinders tested out in cars?
Metal hydride cylinders, they have been tested. Yes. Even in India, not exactly in cars, but yeah, three-wheelers, in motorcycles, these have been tested at BHU, and there are many more such prototypes that will soon will be available as well.
Hydrogen leak detector detects which type of parameter of hydrogen gas while there is a leakage, because as hydrogen is colorless and odorless.
Correct. So this is related to hydrogen sensing, and hydrogen sensors, we have seen that some property of a particular material should change when exposed to hydrogen, whether it is resistance, whether it is thermal conductivity, or some other parameter, resistance. So that material characteristics should change when it comes in contact with hydrogen, and that itself can be used for sensing hydrogen. So yes, you are right. For leak detectors or sensors, you have to find out certain property of that particular, or there is a property of that particular detector which changes when it comes in contact with hydrogen. So as such, you cannot identify. You are right. It is colorless and odorless.
How large a cylinder is needed in car for a typical range of 300 kilometers? For 500 kilometers, compressed saying it is 120 liters.
Okay, so just to give you an estimate for a range of typical range, usually these prototypes which have been already demonstrated and some of the FCVs which have taken which are based on compressed hydrogen. So for
500 kilometer, 5 kg hydrogen stored at 700 bar, it takes 120 liter.
So for Toyota Mirai, like giving you an example, it stores 5 kg of hydrogen so that the vehicle car could have a driving range of 500 kilometers, and it has a tank of 120 liters capacity. Weight of the tank.
Weight,
volume or weight?
Volume, weight was around.
This was around that I will check and I will get back to you. This was roughly around 150 kg tank, and then there are peripherals also. There are different walls and then the balance of plant components. But exact number I will let you know.
It's a fuel cell.
Yeah, Toyota car is a fuel cell based car, not an IC engine based. Yes, yes. Mr. Rajiv, yeah, it's a fuel cell, FCEV. Right. Okay, Mr. Rajiv, that weight you have asked for, volume I told for a fuel cell based car, which is Toyota Mirai, like example I gave you. So the weight is 250 kg for the tank, fuel tank, and the volume is 120 liters.
Can HDPE PVC pipe can be used for hydrogen gas transportation at industrial scale?
Usually, polymer based or PVC pipeline are not preferred because it's considered that the material should have the embrittlement issue won't be there, but then it is that it should be non-porous. So the strength of the material is important. Usually, it is not used for hydrogen transportation.
Is carbon nanotube storage tested out commercially yet?
Carbon nanotubes based storage, there is commercially, it's not been, these are at laboratory scale yet. There are different, it's not only carbon nanotubes, but other carbon nanostructures have also been looked, but there have been certain challenges. As I mentioned, the storage capacity at the atmospheric conditions or the ambient temperature pressure conditions. Then there have been certain cases where the reports they have not those were not repetitive. So the capacities these were not repetitive, and as such these are not as commercially being used for storing.
How is the pressure reduced from high pressure tank at 70 MPa to fuel cell stack in automobile?
So there is a pressure, there is a reducer which is being used for getting the required pressure, and at the fuel cell stack the pressure requirement is very low. So that reducer in between that takes care of that difference in the pressure. What will
What
be
is
the
the
cost?
cost of hydrogen per kg?
Okay, if you remember, after the production, we have discussed about the different cost aspects. We have also talked about like which particular method and feedstock is used, and then what is the associated cost with carbon capture, use and sequestration, and without CCUS. So I would request you to please go to that particular lecture wherein we have in detail talked about from the different routes what is the cost of hydrogen. Any other question if you have, please post in the chat box.
For large consumer like shipping, I have read some Korean ship constructors are using SOFC. Is there any information you have on commercial use of large fuel cells?
SOFC, yeah, it's still not being so widely used. Usually the mature technology is alkaline. PEM also, now the bigger size stacks, they are coming up, they are being commercially now made available. But SOFC, there are, because you require high temperature. So as such, SOFC is not being preferred.
What if we use directly oxygen in fuel cell stack instead of air? Would its efficiency be increased?
Yes, correct. So Prasad, yes, we can use oxygen and then better efficiency. So you have hydrogen oxygen fuel cell. You can use directly oxygen there. Yes, any other question, please post in chat box.
We are reading a lot about ammonia as a hydrogen carrier, especially in shipping. Is combustion of ammonia challenges solved?
Actually, yes, ammonia, especially like Japan, they are much talking about ammonia and its use. And the basic advantage of ammonia is the transportation as against hydrogen, that it has certain advantages. So it's being preferred that you transport ammonia and then either use it or maybe then again get hydrogen from it. It's been known the challenges, since ammonia it has been used for a long time, so the challenges or to how to handle it, it's well known.
Most of the production aspects were covered in the current course. Maybe consider usage aspect in the next semester advanced course.
Okay, so I will definitely consider that. So the production aspects are being considered, but usage also we have tried to uh, see in like ways in which we can use, like using a fuel cell. We have use of hydrogen in fuel cell as well as use of hydrogen in IC engines we have covered in this course. But yeah, definitely will plan for an advanced course later.
Which coolant is used in electrolysis?
Need to check. That I need to check, Prasad.
Uses that we know, but electrolysis.
Okay, so if any further question, please you can either you can post it now here on the chat box or you can write back in the discussion forum.
Can you please tell the control system of electrolysis?
Electrolyzer and fuel cells. I think there are a couple of questions. These are very elaborate, and mm, since this is a very broad course, we could not cover that in this course. Maybe we will have another course specially devoted to electrolyzers and fuel cells.
I would recommend an interesting paper by DOE on definition and production of clean hydrogen, very informative for those interested.
Yes, yeah. Thank you, Mr. Rajiv. So you can share, maybe the others who are joined for this live session, they could also get benefited. Okay, so hope all of you are enjoying this course and having good learning experience. So if there are no further questions, then we would close this session, live session for today. And you can still keep posting your questions in the discussion forum.
Can fuel cell work on CNG along other with hydrogen in automobile?
Yes, there are certain fuel cells which can work on, to Prasad's question I am answering, there are fuel cells which can work on not only hydrogen, but then other fuels as well. Even there are fuel cells which can work on methanol, like the direct methanol fuel cell. They're blending of hydrogen. So yes, there are fuel cells, but then they have to have certain special characteristics. Else, then the challenge is that the catalyst should not get poisoned. So they are sensitive, and as such, these are different fuel cells which can run on other than hydrogen fuel as well. Okay, so my mail ID is pratibha_sharma@iitb.ac.in. You can write to me for other specific questions. And like some of you have asked for the property data sheet, so I can help you out. You can write to me. So this is my mail ID. Okay, then thank you. Thank you for joining this live session. Thank you for attending the course. So we will end this session here. And please write to me if you have any doubt, or you please post your questions in, keep posting in discussion forum. Thank you. Thank you.